So now let's look at the determination of refractive index of a glass using a glass block. That if we have a glass and then we are required to determine its refractive index, and now we are making sure that it is in the form of a glass block. How do we determine the refractive index? And then we can have here a simple drawing for our illustration here. I can call this one P, Q, R, S. Okay? And then I can have here I can have any O, and then X, and then this is A, and then this is a B, and then this is the glass block. If you are to do some labeling, I can call this one pin P3, pin P4, pin P1 and P2. This is my glass block. Okay, so this is not any different from, it is not so much away diverging from the experiment for verifying the Snell's law, only that it differs in the last minute. Okay, but in the whole procedure, we begin by the way we described it. We can say, we can summarize it maybe with some few words and say, place a glass block on a whiteboard, on a white sheet of paper, on a white sheet of paper. The paper will basically be maybe on a whiteboard. Get that block. If you have a white paper on a board, put the glass block and trace its outline, maybe P, Q, R, S, according to the way you have named it. So using a pencil or a pen, trace out the outline, draw out the boundaries. After doing that, you remove the glass block and draw a normal line, any O, on the side SR. Okay? You will now draw a normal line on the side SR. And then after drawing that normal, measure angle I equaling to maybe still such a degree. Okay? Measure angle I equaling to such a degree and draw line A, O, and fix, draw line A, O. And then you can say fix pin P1 and P2. Even if I join this on one statement, and fix pin P1 and P2 along the line. So after drawing that, measure angle 30 there, draw line OA and fix pin P1 and P2. After doing that, replace the glass block, replace the glass block on its outline, okay, while observing from face PQ stack pin P3 and P4 to appear to be in straight line with the pin P1 and P2. Okay? So now, after drawing this, replace the glass block on its outline and then come from this other side. You put pins such that the pins appear to be in straight line with 1 and 3. Put pin P4 and P3. If you've done that, the next step is to remove the glass block and draw line XB through position of pin P1 and P3 and P4 to meet side PQ at X. So now make sure that now you draw a line through these two positions to meet this side here at X. And now after doing that, join point X to point O and measure angle R. Okay? Now, from here you can now join this point here to the other point and measure that angle R. And then after that, you repeat the procedures for various values or different value of I and noting and getting the what while recording also while recording or noting the value of R. And then you can say tabulate your result including values of sin I and sin R. So after varying this I be getting R following the procedure I and R, then record those values. Repeat for different values, recording the values of I and R, okay? And then after that, tabulate your result, including tables of sin I and sin R. And then what we are saying is that you can now plot a graph of sin I against sin R. And then calculate the slope of the graph as S. So we can say the refractive index is given, the refractive index N is given by N equaling to S, where S is the slope and N is the refractive index. So after tabulating, plot a graph of sin I against sin R, against sin R here, that's what I mean, and then calculate the slope of the graph as S, refractive index, it will be given by that. Don't forget, why are we saying the slope is the refractive index? What we can say, the theory of the experiment. we have already seen that we are looking at our rays moving from air to glass. That means that the refractive index is sine I out of sine R. So that means that sine I is equaling to n sine R. So if you compare with y equaling to mx plus c, here we have nothing, okay? So if we compare, we said we are plotting a graph of sine I against sine R. So if we are comparing, there is no intercept, that means it will pass through, okay? It is going to pass maybe through the origin. And now if you compare here this with that with that, it will mean that m is the slope. So it means the slope SC is really true, the refractive index of our glass block. That is how we can basically determine the refractive index of a glass block.